Hey, welcome to another. No, that's not it. Yes, another draft science video presentation. Anyway, alright, so I think I got this kinetic energy thing figured out. And I should have suspected the physics is just absolute crap. It's just nonsense. So, like the two slit experiment, they haven't got any clue at all. They just nowhere even close to reasonable or rational or logical. And it's right there on the top of the Wikipedia page. I guess I should have read it. I didn't think I needed to, but it's just so stupid. So, let's just play along and explain the problem. So let's just premise it. The previous 3 or 4 videos have been on the subject of how you can't maintain the same momentum and claim that two objects have different energies. It's just irrational and nonsensical. The definition of your energy is movement, motion, and mass. That's the definition of energy. So whatever your momentum is, that's your energy, and it takes a certain amount of energy to make a certain amount of momentum. You can't change these rules. So the whole story begins and ends with understanding mass, velocity, and momentum. There's nothing else. Everything else is just bullshit. Alright, and I'll explain the bullshit. So it says right here, in physics, the kinetic energy of an object is the energy that it possesses due to its motion. Well, it's obviously due to its mass and its motion. So they didn't quite get that right. It is defined as work needed to accelerate. So the work needed to get it to its velocity. All right, the mass to the velocity. It takes a certain amount of work. And it takes the same amount of work to stop it. Okay, real work. To accelerate a body to a given of a given mass from rest to its stated velocity. So in the train example, you have 2 trains, one going 12 miles an hour that weighs 1 ton, let's say, and one going 6 miles an hour that weighs 2 tons. That's what you have. The 2 trains have exactly the same momentum. It takes exactly the same amount of energy to move them to those speeds and with those masses. And if I had a spring or something, they would compress it exactly the same amount. If they were in a tug of war, neither one would win. They would just sit there and tug on each other. That's the fact. That's the end of the story. There's no way you can screw this up. Just leave it alone. That's the truth. Now, the fact is, I can create a circumstance, right, where the trains are going off a cliff, and the light train will fly much further, okay? It flies better than the heavy train. The heavy train won't go as far, it'll just kind of fall off the cliff. So, if I measure it and say, oh, that's its energy, but that's not really about energy. That's just about evading gravity, right? See, if you're going fast, then you can evade the gravity for a while. Right? You can fool gravity. It is actually like the cartoons. If you go fast enough, you fooled the gravity. It didn't know you were there. But the fact is, it'll catch up with you eventually. But anyway, this is so bad. It is. You could compare it to a cartoon. This physics is just so bad that Warner Brothers, sort of, you go back to the Roadrunner thing and the Coyote. That's real physics. I mean, real physics is that bad. Okay, so we have the definition, and the definition basically is kinetic energy is motion is momentum. Same thing. All right. I mean, unless you're and the rest, anything potential would have to do with a chemical bomb or would have to do with the environment going to hit you or do something. What you have, your energy, is defined by your motion. So a thing's energy, its ability to, play in the environment itself is defined, its contribution is going to be defined by its motion and its mass. And they're equally important. The mass contribution has just as much meaning as the velocity contribution. The two are not different in any way whatsoever. If I add more mass cubes and I maintain the same velocity, it's just as real, okay, as adding more velocity cubes, keeping the same mass. So it just doesn't matter. they're both the contributor. Without one, you can't have the other. It's not that you can't have it, but I'm just saying they both add up. They both increase your momentum. More velocity blocks, same as more mass blocks in terms of your momentum. All right. Having gained this energy during acceleration, the body maintains this kinetic energy unless its speed changes. Well, it's kind of a silly thing to say, unless another force acts on it to take away its momentum, unless another momentum shows up. Yeah, another mass. Okay. The same amount of work is done by the body when decelerating from its current speed to its state of rest. So in the train example, all of these things are true. All right, so we've established that, okay, kinetic energy-wise, they both have the same energy. They both satisfy the equation. We know it takes the same work to push them, to get them to their speed. It takes exactly the same work to stop them from their moving position. It's equal. Even though one goes further off the cliff, that doesn't mean anything, okay? That's not a good test of your actual energy. That just has to do with whether you can fool gravity or not. All right. So in classical mechanics, so I love when they say that kind of shit, right? So this isn't classical in the sense this isn't Newton's equation. And this nonsense was invented. I remember seeing a documentary that had this whole story in there about this great woman, who actually was, killed by a baby. She got pregnant too late. But, great scientist, all this bullshit, blah, 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 blah. And, they make it out like she did the clay experiments. Apparently she didn't do them. Somebody else did them. And she just sit there and put the results together. And this is the bullshit equation they came up with. Because, they said, oh, look at all this stuff that happens. So the argument is they did some experiments like, okay, I hand you a bowling ball, okay? The fact is I just transferred as much energy as a .45 caliber bullet going 40 miles, 10,000 miles an hour. All right. Now, obviously the bullet, it's the same amount of energy, right? It takes the same amount of energy to move the bowling ball 1 foot in 1 second as it takes to move the bullet, okay, a whole bunch of feet, per second. So, because of the difference in their masses. Same amount of energy, though. And yes, of course, the bullet is going to be it's going to be so much more dramatic. Your funeral and all the blood on the wall and all. Yes, it's more dramatic, the energy, but it's the same amount of energy. The energy didn't change at all. It's just circumstantial, okay, that it looks like more energy. Just like the lighter train going off the cliff looks like it has more energy. It doesn't actually have any more energy. It's the same amount of energy. So this is just so stupid. So they just told us overtly, kinetic energy is momentum. They just said it, okay? They just said it. And the same rules for momentum apply. To get to a certain amount of momentum, you need a certain amount of energy. And it doesn't matter how I mess up with the blocks. I can take mass blocks out and put velocity blocks in. It doesn't matter. The end result is it's always going to be the same equation, mass times velocity. That's your energy. Nothing else is your energy. That's it. Done. Okay, and then they do this piece of crap. All right, anyway, in classical mechanics, the kinetic energy of a non-rotating object, yes, well, of course, the trains aren't rotating, of mass m traveling at speed v is, and they give you a formula that's completely lopsided. Okay, it somehow thinks velocity is all that matters and mass is just totally irrelevant. Couldn't be more of a piece of nothing. You could actually do 1/2 the mass. So you could actually cut the mass in half. So it says 1/2 mv squared. So you actually just separate that equation and just say 1/2 the mass and then the velocity squared. And that is now the definition of energy. Now, they just established that it's the amount of work done to accelerate the object or the amount of work done to stop the object, that is, compress a spring. They just said that's what kinetic energy is. So now in the train example, where just a minute ago, by definition, they had exactly the same kinetic energy, by the definition, Okay, how much energy does it take to move them and how much energy does it take to stop them? They have exactly the same kinetic energy by definition, and now by formula, it's completely different. Now all of a sudden the heavier object has much, much less energy than this faster object has much, much more energy. Twice as much. Actually, twice as much energy. So even though in a tug of war there it's a draw, it doesn't matter. It has twice as much energy somehow because the formula says so. Now, the formula was written because there was just this observation of the lighter train flies off the cliff. Okay, it actually flies. Like if I make the train lighter and lighter, I can make it go further and further and make the other train look so lame because the other train is so bad at flying. But as you understand, I think, okay, is that your car has a lot more horsepower than the average plane. Well, something like that anyway. That takes a lot less to move the light object through the air than it takes to move the heavy object on the ground. Energy-wise. So let's see where else to go with this. There's just nothing to say. This is where this whole thing broke. Is the equation has nothing to do with reality. It's a complete denial of reality, and it's all based on this idea too of where they say, the faster. Like if I double the speed of a car, it's 4 times now. 4 times as much energy. No. And they're doing it based on how quickly you can brake the car. That is how well the brakes work. Well, as I just sort of pointed out, you can sneak by gravity, right? So the faster you're going, the less time gravity has to push you down, right? So your tires don't weigh as much. The faster you go, it's like literally true that your car gets less, there's less weight pushing down on the ground, because there's less time for gravity to do its work, because of your speed. You're outrunning the gravity in a sense. And so there's less friction. So that's one reason why it's harder to put the brakes on and stop the faster car. Okay, and then the other reason is that you didn't make the tires bigger. So you made the car heavier, or you made the car go twice as fast, but you didn't make the wheelbase bigger. So it's the same surface area for twice the velocity. I mean, obviously that's not going to work, right? So, unless you increase how big the tires are proportionally, of course you're going to end up with having a harder time stopping. Right, you would expect it to be twice as hard because it's going twice as fast. Instead, it's 4 times as hard. Well, it's 4 times as hard because you didn't make the damn wheels bigger. But if you make the wheels bigger and then you make the asphalt more lumpy, okay, bigger lumps in the asphalt, and all these things matter. So all this equation is written for is this is a human-centric equation. This equation has to do with the fact that our skin, our chemistry can be ripped apart at certain velocities. Certain velocities, all of our eggshell breaks, and that's all this is about. It's not about physics. It's not about science. It's about human perception again. Again, they're sitting there humanizing the physics. They're saying, well, make it more my world. Make it more how I live. And, the world I live in, it takes a certain amount of heat and then it catches fire, right? So their argument is that if I shoot 2 bullets at a tree, and I shoot one slow and the tree doesn't catch fire, and I shoot one fast and the tree catches fire, somehow that means the bullet had more energy because the tree caught fire. So obviously in a collision where you're going faster, what you end up doing is creating a bunch of extra chemical energy. You end up making stuff melt and burn. So pieces that weren't creating any extra energy are now making extra energy. So the more you rip the chemistry apart, the more electricity you create, the more little ions you create, the more electrons flying around. So it's more like it's more like when we're shooting something or when you're interacting with something that is dynamite itself. It's a little firecracker. And the fact is that if you poke it hard and fast, you can make it catch fire. And so it's adding to the effect of the collision. It's not about the energy you brought. It's about the energy you're creating. You're causing chain reactions. right? So it's not about the energy. It's really not. It's like if I shoot a few neutrons into a radioactive material and cause it to explode, it's not because the neutrons had, special energy. It's just the fact that if I shoot them at a certain speed, they're able to accomplish the task, and if I do it slower, they don't. But if I want to knock a building over, I want the big, heavy, slow train, not the fast train, right? I don't want to bore a hole in the building. No, I want to knock its foundation down. So I want a big, heavy train that doesn't make a hole and it breaks everything into pieces. And then the building falls down. Does that mean that train had more energy? No, it didn't have one tiny joule more energy. So here they've turned a formula that's just a gross approximation for a causal effect, a circumstantial effect, and they're calling that the hard physics. They're sitting there overtly saying, do this formula to tell you how many joules of energy you have. It's just nonsense. It's not the truth. And it's overtly not the truth, as in the train example. The momentum is the definition of how much energy the two objects possess. Okay, and it just really doesn't matter that one affects, eggs a certain way, and one affects tomatoes another way, and one affects houses a certain way, and one flies off cliffs a certain way. All of that crap doesn't matter. The fact that they circumstantially can do different kinds of work doesn't have anything to do with the fact that they carry a certain amount of energy, and that's it. That's what they have, a certain amount of momentum, real energy. So this whole thing is just it's just amazing. So they think this 1/2 mv squared is a real scientific equation when it's overtly wrong. It doesn't get the right answer. It won't tell you the truth. Okay, the train going 6 miles an hour that weighs 2 tons has just as much energy as the train weighing 1 ton going 12 miles an hour. And it's just the absolute truth. That's the fact. And that equation gets the wrong answer. So I always hated it, and now I know why I hated it. Because it's nonsense. It doesn't make any sense. It's stupid. All right, so let's go down here just to verify the clay story. Because it's in here somewhere. Blah 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 blah. Well, here's the equation, right? But the funny part is right down here, they show these two equations, and so here's the 1/2 mv squared, and that's transitional kinetic energy, translational. And right here it says the kinetic energy of object related to its momentum by this equation. This is the one she should have been using. Now you get the same answer, but it has momentum squared divided by 2m. It is a different equation. This is the one you use when you're changing the mass. When the mass remains the same, that's when you're supposed to be using this 1/2 mv squared bullshit. So she wasn't using the right equation anyway. But the fact that she's using this equation, any physicist is using this equation, he's not going to get right answers. Because the equation is absolute nonsense. There is no extra energy. And it's just this big a nonsense is the, de Broglie nonsense that, everything has a frequency and, that's our energy. It's just nonsense. And, here it is, a point object. This is more nonsense. Nothing's a point object. So more crap. Everything has a real place in space. So, yeah, somewhere in here is the whole clay story. Overview. Energy occurs in form, chemical transform, demonstrate. Bicyclists and stuff. Here's the history. So the E is proportional to. See, they didn't even say equal sign here. So now they've put an equal sign in an equation that was talking more like kind of there's a proportional relationship. mv squared. So it's not even 1/2 mv squared. Okay, so energy energy is proportional to mass times velocity squared, and we don't even have the half in here. was first developed by Gottfried Leibniz. Anyway, so in here they say, who describe kinetic energy as the living force. Isn't that special? So then we say dropping weights from different heights into a block of clay. So again, this is about friction and about how to apply a stopping force. Obviously, the block of clay isn't a very good way because the clay deforms, so it's not like a spring, so it's not any kind of rational way to measure the absolute energy of the object. It's a pretty poor way to measure its energy. So you're really just talking about how much it disturbs chemistry. And so again, that's what they've turned it into. It's not about what the thing has, it's about how it affects us. Or some kind of crap like that. And it's just wrong. And I don't know why I don't understand why they think this is a rational way to do physics when their formula gets overtly the wrong answer. When it overtly tells you that something that has the same energy, takes the same energy to make it move, takes this to get out up to speed, takes the same energy to accelerate it as it takes to decelerate it. It's exactly the same amount of energy. It's just a fact. And your formula says, no, this one took twice as much energy to move, even though it didn't take twice as much energy to move it. And even though it won't take twice as much energy to stop it, you're saying that it does. Your formula says something that's just not true. So why are you using it? It's overtly wrong. Why are they using it? It gets the wrong answer. I mean, it's overtly wrong answer. Why are they using it? I mean, it's not just a rhetorical question. I mean, I'd like somebody to answer the question. Why are you using a formula that overtly gets the wrong answer? Just overtly. I mean, the two trains are sitting there in their tug of war, right? And they're going to write right over the train, this train has twice as much energy as this train. Even though the tug of war is showing that the one that has twice as much energy isn't winning. Okay, yeah, that's all. That's enough. So, some guy did email me. He had a whole theory. I always think maybe this is just a timed event, so they're saying how much energy can it deliver per second or per microsecond, and so then velocity would matter. And I tried to figure out some way to save this, but there's just no way. The formula is a piece of garbage. Okay, it has nothing to do with real energy. It just has to do with the circumstance that chemistry breaks down, okay, at certain speeds, that you start to melt things, you start to break them down in different ways, and so obviously speed sort of becomes important. Just like speed is important if you want to fly off the cliff. Or if you want to get off the cliff, you got to reduce your mass and increase your speed to fly further. But it doesn't have anything to do with how much energy you have. Okay, flying doesn't have anything to do with it. Yeah, I think I've made it as clear as I can make it. So it's obviously a bullshit formula. It was bullshit as she's showing it. It was just right there in front of you. Somehow it lost, and then she started talking about deformation and all this stuff. How could it have the same momentum? Again, I mean, it's such a simple argument. How could it have retained? How could the train have the same momentum after the event of pushing? It now has the same exact momentum. That is, all you did was reduce the speed and increase the mass proportionally, and there were no losses, and then say, no, there was a whole bunch of losses. Half the energy was lost and deformation. I mean, it was so stupid. So anyway, yeah, I've done all I can do. All I can do is reason with you people. If you're unreasonable, you're unreasonable. You want to believe in the fairies, go ahead and believe in fairies. It's overtly nonsense. That they could say, oh, this is just a nice approximation. It says right here, a good approximation. In relativistic mechanics, this is a good approximation. Yeah, oh, okay. Only when v is much less than the speed of light. Well, it's also a terrible approximation when you're using trains as analogies because it fails completely. But it would fail in the car example. The car doesn't have 4 times more energy when you double its speed. It doesn't. Okay, all it has is more capacity to evade gravity and plow through matter. Separate matter into bigger chunks, and then accelerate pieces at higher speeds. It has capacity to screw matter up because of matter's weakness, not because the car has more energy. It's because it's broken the threshold of how strong matter bonds are. The chemical bonds aren't infinitely strong. They can't infinitely fight back. They're an eggshell. So yeah, I can hit an egg with a certain amount of energy and not much happens at all. But a certain amount of energy, a certain, and I have to have it, I can't spread it over a cotton ball. I have to poke the energy in a quick manner. And then once I perforate the shell of the egg, it looks dramatically like I did a lot more to it, like it was a lot more energy somehow. But it would be the same exact amount of energy. I can hit it with one form of the energy and the eggshell doesn't break. I hit it with another form of the energy and the eggshell breaks. It doesn't mean I have more energy. And this equation is trying to imply that it's true, it's more energy because you hit it, okay, with a spear, instead of a watermelon. No, same energy. Okay, yeah, it really should be enough. All right. So this has been a draft science video presentation. Thank you for your support. Well, the exact opposite is what I mostly get, but whatever. Yeah. Thank you for your participation. No, I can't thank you for that. Oh, forget it. I won't bother thanking you. That makes it easier. Hell with that.